Next section, we're going to take this knowledge that we have about doing truth tables and about statements and looking at the results, and we are going to now compare different statements. Okay, so this whole section is going to be about what makes statements equivalent. Now, in case you don't know what that word equivalent means, that's great. That's why we're here. Two statements are equivalent. The logic symbol for equivalent is equal sign, and then you put arrows on the ends of the equal sign. So two statements are called equivalent if both have exactly, okay, I'm going to underline the word exactly, if both have exactly the same truth values in the answer columns. Same truth values, same places. So just as a quick example of that, there's not really much more to say. I would like you, using this truth table, do a truth column for P and in parentheses, Q or R, and then do a truth column for P and Q or P and R. And we want to know, are these two things equivalent? Yes or no? Okay, so I'm going to give you 2 or 3 or 4 minutes to go ahead and do as much of the truth table as you can. All right, so when you're doing this and your homework, you can do 2 separate truth tables. That's fine. We're just going to do this all in this one long truth table. So first, I'm going to work on the statement on the left, and I'm going to do a column for Q or R. The or statement is true when either one is true. So going down the Q or R columns, I've got true, 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 false. If you get anything different than me, let me know so we can talk about it. Want to make sure we're clear and getting these basic truth facts into our long-term memory. So that's the Q or R. The only other thing I need to do for this statement now is I'm going to take statement P and I'm going to AND it with that Q or R column. So the AND statement is true when both are true. That's the only condition. So I'm just going to put a little dot. I'm looking at P. I'm looking at Q or R. Put a little purple dot over both of those. So the first row is true and true. Second, true and true. Third, true and true. Fourth, true and false. Fifth, false and true. In fact, I see that all the rest of them are going to start with a false, so all the rest of them are going to end up being false. So for the statement on the left, the truth table column turns out to be 3 trues at the top, 5 falses at the bottom. Okay, so I'm just going to put a little star underneath that because I'm going to compare that column with the end result I get for the thing on the right. And if they are exactly the same in every way, then we have equivalent statements. If they differ at all, okay, if there's a true in a different place or if there's a different number of trues, then they are not equivalent. So on the left, I'm going to do these parentheses first. So I'm going to do the P and Q. So the and statement, I'm just going to run my finger down the P and the Q. Again, just like we saw a second ago, and is true when both are true. So I have true and true, true and true. And then all the rest of these, I think, are going to involve a false somewhere. So all the rest of these are going to be false. The other parentheses is P and R. So I'm going to go down the P and I'm going to go down the R column, put a little orange dot just so that I keep that in mind. So the P and the R column. So I have true and true, true and false, true and true, true and false, false and true, false and false, false and true, false and false. So I have the first and the third are true on that one. And now at long last, I'm going to take those 2 orange columns, I'm going to connect them with an or statement. Okay, so I'm going to take this one, I'm going to check mark, this one I'm going to check mark, and I'm connecting it with the or. The or is a weaker statement than the and. The or statement is if either one of them is true, you are true. So I have true or true, true or false, false or true, false or false, false or false. I think all the rest of them are false or falses. Put a star right there. Now, the last question. Do I have the exact same columns at the end of both of those? Yes. I've got 3 trues, 5 falses. 3 trues, 5 falses. So the answer, are these 2 things equivalent? And the answer is yes. And we'll put an exclamation point because there's a lot of work there. Okay, it was yes because those columns are the same. So that's pretty much what equivalence means. And so the way we'll spend the rest of our time this section and today, and then we'll finish it up when we get together next time on Thursday, is we're just going to look at 3 special shortcuts we have to equivalence, things we can take to the bank that are going to be equivalent. So the first one is what's called DeMorgan's laws. Okay. Named for the mathematician who was really most famous for the stuff that he did in inventing logic and making arguments and things like that. What DeMorgan's laws kind of give us is what we might call, I'm going to put in quotation marks here, and I'm going to go over what we would call is like a distributive property. If you remember your arithmetic, a distributive property. A way that I can take that negation and I can clear the parentheses. So there's one thing you've got to be careful of when you use DeMorgan's laws, and it is this. When I have a negation out front, okay, I can say that this is equivalent, my equal sign with arrows on the sides, to this. Well, I can distribute the squiggly, a squiggly P. I'm going to leave a little space. Don't put anything right there just now. That's the trick here. And then I have a squiggly Q. I just made both of those statements negative. But here's the gist of DeMorgan's law. If it starts out in parentheses as an and, when you distribute, you got to make it an or. Okay, you got to flip that sign over. So do me a favor. I've shown you DeMorgan's laws when we distribute and there's an and statement. Make a hypothesis, write down what you think the next one is equivalent to. Same pattern, just want you to write it down and think it out. Okay, so hopefully you distributed the negation. So squiggly P. I'm going to leave a little space, squiggly Q. But now, instead of an or, instead of a V, what are you going to put between the two? and. Perfect. You guys did great. I appreciate that. So just as an exercise on equivalence, I'm giving you a shorter one than we did before. I don't think we have too many truth tables left in this section because I know we're all exhausted of them. What I would like you to do is just verify. Okay, I've told you that that's true. You can take it to the bank from now on, but you're going to verify that the squiggly and then P or Q in parentheses is indeed equivalent to squiggly P and squiggly Q. So the first one in parentheses, I've got the P or Q, so I'm going to start in the parentheses with that. The or statement is true when either one is true, so I've got true or true, so that's true. True or false, that's true. False or true, that's true. False or false, that's false. And then the squiggly out front just means take that green column that I have right there, and we're going to make the exact opposite truth values. So instead of 3 trues and a false, it's going to be 3 falses and a true. And I'm going to put a little star below it because we are verifying that these two things are equivalent. We're looking for the exact same truth values. The second statement, I need the negations, so I'll do those first. I need a squiggly P. So squiggly P, instead of being 2 trues and 2 falses, is going to be 2 falses and 2 trues. Squiggly Q, instead of being true, false, it's going to be false, true, false, true. And now what I'm doing is I'm connecting those two things together, those 2 red columns with an and. And so hopefully now you see, once we go through this, that you get the exact same thing, and you've just proven this. Okay, so I know we don't like the word proving something, but that's what you just did. You've shown that no matter what, these two things are going to be true. So false and false is false. False and true, false. True and false, false. The last one is true and true. We get true, and there we go. We have the exact same thing. 3 falses, 1 true in the last column. So you have just done what I asked, which is show or demonstrate or prove that these two things are equivalent. Okay, so we're going to use DeMorgan's laws a couple times without doing a truth table. Yes.
I did it like a little backwards. I put the squiggly Q first, and then I did the P or Q. I didn't do it the same order.
As long as you have these same 2 columns somewhere, and they're both 3 falses and 1 true, you're great. Yeah, you can do some of the busy work like the parentheses and the negations first, and then do the final stuff last. Yeah, all of that, the order of those columns don't matter at all. Great question. I'm sure somebody else in here has the same one. All right, so exercise 3, we're going to just step through this. What we're going to do is we've got a statement here, and we're going to use DeMorgan's laws to rewrite it. We're not going to do a truth table. Okay, so the statement is the dog was not a bulldog and the dog was not a boxer. So first thing, define the simple statements. Okay, 30 seconds. Write down what you think those simple statements are going to be. Okay, so starts off, the dog was not a bulldog. So statement P, the dog was a bulldog. And the dog was not a boxer. So statement Q is the dog was a boxer. So next thing, I'm going to give you 25 seconds. I want you to write this statement that was in words. I want you to write it in symbols right here, right next door. Okay, the dog was not a bulldog. What is that? Squiggly P. And it's going to be the and symbol, the thing that looks like an A without the cross through it. And then the dog was not a boxer. That is squiggly Q. Great. So then here's what you're going to do. Now, I understand after you've done a couple of these, I fully expect most, all of you to be able to write a statement using DeMorgan's laws. You probably don't have to go through the whole symbolic thing. I get that. Okay, so do a couple, practice it, and if it clicks, great. You don't have to do all this. You can just go right to writing the statement. But here's DeMorgan's law. I can use DeMorgan's law in reverse if you need to go up to compare. What I'm going to do is I'm going to take the squiggly out. I'm going to kind of factor it, for lack of a appropriate word in logic. So then I'm going to have a P. I'm going to have a Q. And then what is the key? What does DeMorgan's law say happens to this symbol? Instead of an and, it's going to be a what? It's going to be an or. Right. And now this, again, this is a blast from the past from last week when we talked about writing things in words. Make a hypothesis. What is it when I write this right-hand side using DeMorgan's laws? What do I get when I write it in words? So give you 30 seconds to propose what you think it's going to be. What did we say in section 3.1? We write when we have a squiggly out in front of parentheses. Anybody remember? Yes, great, good memory. Okay, when there's a squiggly out in front of parentheses, you start off by saying it is false that, or it is not true that. And then inside the parentheses, I've got statement P. So it is false that the dog was a bulldog. Or Q, the dog was a boxer. Done. After you're done writing that, I believe at the top of the next page, I have another example just to make sure we're comfortable writing things in words and symbols and all that good stuff. So turn the page and begin that. I'll leave this up here in case anybody's still writing. I'm going to leave it. I didn't leave space on this one, but if you need to define your simple statements, do that. Okay, do the work that you need to do to be able to use DeMorgan's laws to write this as an equivalent statement. All right, so I'm going to go through the whole thing, but again, you do as much work as you need to do to be able to accurately write this equivalently using DeMorgan's laws. Okay, so some of you are going to write all of this down. Others of you at this point, maybe it flashed for you and you're good to go. Just do what's best for you. So my statement is the sun is not shining, but somebody asked this last time. That's why I put this on as an example. The word but means and I think the homework mentioned it, and I forgot to in class, and I apologize, and somebody either in this class or my other asked me that, and so I wanted to make sure I intentionally mentioned it. So if you didn't realize that, I'm not trying to goof with you or anything. I just wanted to make sure I spoke it out here. So I've got P, I've got Q. So the sun is not shining, but it is raining. So statement P is the sun is shining. And then statement Q is it is raining. Trying to keep the statements short because I know we've been doing a lot of writing. So I'm going to write this in symbolic form. The sun is not shining, so that is squiggly P. The word but means and, so if you propose that it was or because I hadn't mentioned that before, well, I apologize. And then it is raining is Q. The reason I gave this example is now we're applying DeMorgan's law. The previous one, both of them were negative. This one, only one is. And so just wanted to make sure that, again, I like to mention everything that can possibly happen so that there's no confusion. So I'm going to factor out that squiggly. Okay. So what happens to the squiggly P when I get rid of the squiggly? What does it become? Just P. DeMorgan's law says that this and is going to become a what? Now here's the new bit, and if you didn't quite get this, that's all right. That's why we cover this in our examples. What do you think Q is going to become when I remove the negative? Perfect. Yeah, two negatives make a positive, so squiggly Q. Great. So a negative of a negative, if I redistribute, a negative of a negative makes that plain old positive Q. And so then DeMorgan's law of this statement right here, I'm sorry, we've used DeMorgan's law. So now writing this out, there's a squiggly out in front. So that means it is false that, or you can write it is not true that if you prefer. It is false that P, the sun is shining. Or, and then squiggly Q, it is not raining. All right, this is going to be our last problem of the day. This is a great breaking point between DeMorgan's laws and the last two equivalences that we can take to the bank. So it's just one more exercise, same sort of thing. So I've given you a problem, rewrite it, do as much work as you need to using DeMorgan's law to write the equivalent statement. Okay, so my simple statements. So my statement, my compound statement is, it is false that I did not pass the test or I studied too much. So I'm going to make statement P, I did pass the test. And then statement Q is, I studied too much. I'm now going to write this the way it was given to me symbolically. This, it is false that, we've already seen a couple times, means I'm going to start off with a squiggly and some parentheses. And in the parentheses, it says I did not pass the test, so squiggly P. The word or, and then I studied too much, which is Q. DeMorgan's law says I am now going to distribute that negation, so let's do that. So a squiggly of a negative makes positive P. DeMorgan's law says always flip that sign, so it's going to become an and. And then a squiggly Q is what the result is there. And so last but not least, I take that statement, I'm going to write it in words. This is the cool down part of the problem. So P is I did pass the test. And squiggly Q, I didn't study too much.